Hello and welcome back. Having discussed Newton's first law of motion, which dealt with a situation where there was no external force, and Newton's second law of motion, which related to how an object's motion changes when there is an external force applied, it's now time to understand this thing called force a little better. First, we'll talk about how every force has both an object and an agent, and we'll discuss ways in which we can identify objects and agents correctly as a crucial step in solving motion problems. And secondly, we will recall that force as a vector has magnitude and direction, and specifically when we deal with the magnitude of force, we need to be concerned with its unit, so we will talk about what the unit of force is.
So what exactly is force? It turns out that this simple concept is quite hard to define precisely, but for our purposes, we can think of forces as a push or a pull. Now, this push or pull has to be applied on an object by another object or something else. So whenever we talk about a force, it does not exist in isolation. It is intimately related to an object that the force is applied on and related to an agent that's responsible for applying the force. So let's take an example. If I am pushing a box down the floor in this direction, and if I'm interested in studying the motion of the box becomes the object of interest. And the pushing force on the box is applied by me. So in this case, for the pushing force, I am the agent. Secondly, you know that the box has a weight, and weight is a force. The agent for the weight is the earth, which is responsible for the weight of the box. So we have discussed two forces on one object. The pushing force, which is applied by me, so I'm the agent, and the weight of the box, which is a force of gravitational attraction from the earth, so the earth is the agent. Third, force as a vector has magnitude and direction. For now, let's talk about the magnitude. When we specify the magnitude of a force, we got to specify units to go along with it. So what is the unit of force? We can use equations to derive units for entities, and we know the equation F equal to ma, which we discussed as the equation form of Newton's second law. And we know the standard international units for mass and acceleration. For mass, the unit is kilogram, and for the acceleration, the unit is meters per second squared. So since force equals mass times acceleration, the unit of force is simply kilogram meter per second squared. That is the standard international unit of force. Now you'll see in science that when we have correct but cumbersome units like this, we tend to give them a different name. And in this case, we call this kilogram meter per second squared, we give it a new name called Newton, in honor of the scientist who has prescribed the laws of motion. So the SI unit of force is Newton, which is written as just a capital N. And as we have seen here, 1 Newton is simply 1 kilogram meter per second squared.
So in this slice of physics, we focused on force, which is the central concept in Newton's laws and an object's motions. We first looked at how a force does not exist in isolation but relates to a very specific object-agent pair. And secondly, as a vector, we recalled that force has magnitude and direction. And specifically talking about magnitude, we looked at the unit of force, which in SI units is called Newton.